Hi guys, today we'll look into this problem search insert position. So what we will get here, given a sorted array and a target value. So we have to return the index of the target is found. If we found the target, we will return the index. If not, return the index where it would be if it were inserted in order. Let's understand what's the question. Okay, so how we have to solve this question? Search insert position. First we have to observe that what was given. So given we have sorted number of arrays. Second, no duplicate. Well, that's good. Okay, what is required from this? From requirement, they are expecting first, now they will give us some target number. Target will be some number, might be 7 or 6 or anything, and we have to find if that number exists in the array. We have to return the index. If number exists, the target. If it doesn't exist, we have to tell the position where it should be in ordered way. So if it doesn't exist, we go through with some example. We try to see what particle algorithm we can use for this. But when we observe with the word sorted, we should know that we have to use binary search because there is a sorted array, and we can use binary search that will give log of n complexity. Some basic example. Shouldn't go with the corner cases. No corner cases. No corner cases at the very start, so that we could develop our some ideas. So what is a basic example here will be might be 1, 2, 3, 6 and 7, and the target value will be, let's suppose, 6 for sure. We can see 6 is already here. And to find this 6, we can go with a binary search. Pretty simple. This is the left index here, right index on the other side, and we will find the mid. Mid will initially point here. First we will make some strategy. Strategy would be yielding some decision. So that strategy depends on what, on the given part, what is given. So given things are sorted array, and second, no duplicates. So it is very simple example. Hopefully in some other question we will get duplicates also, then that strategy would change. So currently with the given data sorted, with this sorted and no duplicates, these two information, we can make the plain simple strategy of binary search. There is one use case also. We will also go through some corner cases that if that number doesn't exist, we will see it later. But let's go with the binary search. What will be the view? Example would be, let's suppose we take 1, 2, 3, 5 and 7. Target is 5. In the binary search, what we do normally, we take left index, left pointer, which is pointing at 0. We take the right pointer, which is pointing at the end, and we calculate mid by using the approach that left plus r minus left divided by 2. Mid will be pointing here, and at this point we try to make some strategy. We make a plan. We see that if the nums at mid is equal to my target, so return that mid point. So this will be our answer. That would be. So let's go and write the code up to that. So we take left, which is initialized with 0, right, which is initialized with nums dot length -1. We make a while loop where the condition will be left is less than equal to right. So we will be in valid iteration. So that part is looking for while loop. Next we will find the mid. So here we will find mid. That mid would be some midpoint that will be left plus right minus left divided by 2. That part is for finding the midpoint. Second, we have to make some strategy here. That strategy will give some decision, will yield some decision about our sorted array. What it will be? It will be for the binary search that if this is the midpoint and the number at this position is not equal to, or it is less than, or it is greater than. So that number at this position at mid is less than my target, is less than my target, or it is greater than my target, or it is equal to my target. So for equal to target, for sure we will return the answer. Mid will be the answer. The other cases would be when the number at this position is less than t, or it is greater than t. In that case we have to make a plan. So what will be the plan for this? This condition, we would say, I'm talking about that whole part. It would be if nums at position mid is equal to my target, then return mid. Else, if might be that number at mid is less than my target. If it is less than, what should I do? For sure I will make a decision. I would say I have to skip if that number here is 4, which is less than my target. So I will not look here. I will skip all that part. So this will be gone and I will only look into this area. That area will be considered because it is sorted array, and for sorted array that if this number is less than my target, so for sure my target won't be here. I will look here. So what should I do? I have to adjust my left pointer. So left has to be adjusted. So right would remain here, left will be shifted at some place further. Left has to move ahead. Ahead of what? Ahead of my left has to move mid plus 1. So it should point here. That left should come here at this position. If we say else, the second case when the number is greater than t, so for sure we have to adjust. In that case right has to be adjusted, so right will be moved one step back. So right will middle minus 1. Let's go with example step by step how it will work. Now we talk about this plain example. Initially left is here, right is here, mid is pointing at this position. We see with that line of code that this is not equal to. We'll move ahead and then we'll see nums at midpoint is less than my target because our target is 5 and this number is less than 5. So we have to skip that whole part and we have to move here. What we have done, we will shift our left. So now the second state would be 1, 2, 3, 5 and 7. Left would be pointing at this position. My right will remain here, and now again we will calculate the midpoint. Mid will be, as we can see, index will be 0, 1, 2, 3 and 4. Mid will be calculated like 3 plus 4 minus 3 divided by 2, and that will yield 3 plus 1 by 2, that will be 3. So mid will point at 3, so mid will come here. In that case we can see that they both are pointing on the same position. And now when we come to that part, we will get the target, we will return the answer mid. This is correct. Go for the next use case. When we talk about that, let's suppose we have 2, 3, when D doesn't exist. In this use case, what we have to do, let's suppose we have 2, 3, 4, 6, and 8, and our target, say it will be target is 0. Now what we will do, we will keep our left at the very start, we will keep our right at the end, and we'll find the middle. For finding middle, it will go with the 0, 1, 2, 3, and 4 index. So middle will be is going to point at 2, so middle will come here. Now for that 4 is greater than my 0, so we are actually at this position, because nums at mid is not less than our target, it is greater than, so we will adjust our right. So when we will adjust right, that right will move here. The next stage will be 2, 3, 4, 6, and 8. Now when we are going to adjust the right, so right will come here, left will remain there. Again, we'll find the mid, so mid will point now to 0, so mid will come here, and again we will see conditions from here. So num is not equal to target at the middle, and else if nums at mid is less than t. Now it is not less than t because this is 2 and our target is 0, it is greater than, so we have to adjust right again. When we will adjust right, currently right is positioning at this index. When we will say m-1, it will come here, so it would start pointing some number here, which is actually -1. So our right will come here in the next iteration. Now when right is going beyond the array limit, so that condition of loop will break that part. So left is now greater than to the right, it will break. We will come out and see this left is actually pointing at index 0. At index 0 we are still pointing that. If we want to adjust that 0 in this array, so it should be on index 0, and all of them will shift further, 2, 3, 4, 6, and 8. So our left was standing on the position where that number should be adjusted. Let's take another example. 2, 3, 4, 5, and 6. Target is 8. For this particular case, again, left will be here, right is going to point at this position, mid will come here. Mid is less than our target. For sure, we have to shift our left to next of the mid, and in the next place will be 2, 3, 4, 5, and 6. Now left is going to point at this index and right is at 6. Now mid will be calculated, it will come here. Again, that 5 is less than the target, we will adjust again left, and in the next iteration left will go here. So because left was expecting that number should be in this position at some of this range, then this loop will break by considering all these conditions, and left is again on the right place where that target value should be. Now think about another example. Let's suppose we have 2, 6, 8, 10, and 12. Target value say 4. In this case, what's going to happen, that value should be actually within this range. It should be between 2 and 6. So again, take the left here, take the right, and mid is going to point at this position. Mid is greater than my target, and that left will that right has to be moved, so right will moved here, at this position at 6. It is pointing now to 6. Now 6 is again greater than my target. Now at this stage we would calculate for the mid. Mid will point at this index. Now we see that this 2 is less than our t. In this case, what we have to adjust, we have to adjust our left. We have to adjust left. Now to adjust left, it will move further. So we will move it ahead. In this case, make it more clean. 2, 6, 8, 10, and 12. So right will remain on its position. Left will move ahead. Mid plus 1. So left is also pointing here. Previously, mid was pointing at this position. Now we will calculate mid. It will come here on the same spot at this position. Now 6 is greater than my target. So 6 is greater than my target. For this use case, right has to be shifted here. Right will move here and it will point. Now left is greater than, that left index is greater than the right index, and that while loop will break. This while loop will break, and when we will break, we see that our left is pointing at index 1. So if that number has to be adjusted, so it will be 2, 4, it should be on index 1, and 6, and 8, and 10, and 12. So we can see that using binary search, we can just make a particular strategy, and that strategy will yield some decision, and we can get the result. Let's see how we can code cleanly. Welcome back. Now let's code what we have learned. So we can say we can go with the binary search, and we take var left, which is 0, and var right, that is pointing nums dot length -1, and I can use my while loop where left is less than equal to my right, and I can say I will go and find my mid. So mid will be left plus right minus I can use a parenthesis to make it clear, left divided by 2. Now after that, I will make my strategy, and here that will be if my nums at mid is equal to my target. So it means that number exists in the provided array, and we can return the mid. And we have to return here. Else, if it is not there, but the number at mid is less than target, so we have to move right. We have to move left and look into the right side. So we have to move left up to mid plus 1. Else, if the number at the mid is greater than target, we have to find target on the left side of the array. So we have to adjust our right. So that will be mid minus 1. And we can return left at the end. Let's run the code. Here we get the answer. Thanks.